Hello everybody, today you will learn how to make your very own high power slower excited This circuit is a popular Slayer Excited circuit, except I've beefed this one up, and it gets so hot it needs a big heatsink and a fan to cool it down. So I shall show you how to make it. Step 1 is to make the coil. This is a Tesla coil. It is made up of a few turns of one wire and many turns of a second wire. So, how to make this? First of all, you want to make your so-called secondary, which is all these wires. So what I did is I just grabbed a garden pipe, and it's been cut. Now, the dimensions don't really matter, but if you want a really powerful Tesla coil, you don't have to do this, but you want to aim that whatever your diameter is, your height is exactly 5 times taller than the diameter, so a 5-to-1 ratio, but if it's close enough it works fine. So all I did was stick a screwdriver, the handle of it, in here, and then that into a drill, got some wire and wound it. Now when you're winding this, you just want to carefully use your hand and make sure you push all the wires together. I didn't do a very good job. There are some gaps. You don't want to overlay it or gap it. But no, it's close. Like, yeah, see, look at that. That's a big gap. Now all you have to do is go from the bottom all the way to the top and then out. You don't go back and forth because you'll be putting very high voltages next to each other, and that will break your Tesla coil. Do not connect wire together. Use thin wire, and just make sure you tape everything down and glue it so you don't, so everything doesn't come loose. And then just put tape all over that so it doesn't come loose and you don't scratch it. And then put some electrical tape on the top and the bottom, and then put some electrical tape around it's about a centimeter or so, maybe 2 centimeters from the start of your winding. So my wire goes in through the base up to here, and then it starts doing all the windings. So around 2 centimeters or so from the start of your winding, just put some more electrical tape, and then wrap, in this case it's 3 turns of wire around here, and make sure it's thick wire because this is where all the current will be running. Also, if you're wondering how many turns there are on this secondary, there is around about 250 turns of secondary wire. Now here is the circuitry. It looks pretty complicated, but it's really not that hard to build. So I shall show you how to build this. I'm going to dismantle it and rebuild it again. So here are all the components you need. Really, it's just 2. These are tip, it's not showing. These are tip 31Cs, 2 of them, on a heatsink, on a big heatsink, and even so I'm going to put a fan on it. 2 resistors. These are just get as close as you can to 50 kilo ohm, but I'm pretty sure these are like 46 kilo ohm, and it works fine. And 2 diodes. Not too sure what diodes these are, but really any diode can handle at least 30 volts, and at least 1 amp will work fine. And then just 2 1 microfarad capacitors. Make sure these are not electrolytic, because they will explode if they are electrolytic. And yeah, that's really it. Oh yeah, and lots of connections. Start off by grabbing the transistors and inserting them somewhere on your board. I'm just going to put mine, that's not working. I'm just going to put mine here on my board, on your breadboard, like so. Then grab a resistor, and between the positive rail, and the base of your transistor, place your resistor. Do that for both transistors. Now that you have done that, and put it on the base of both transistors, grab your diodes. Make sure the stripe is facing away from the negative pole and put those between the negative and the base of your transistor. Make sure the stripe is facing away towards the transistor. I don't know if I can put this in without using two hands. Now that you have done that for both transistors, just grab a simple jumper wire and connect the base of one transistor to the base of another transistor. I can't do this, but you get the idea. Now that you have connected the bases of each transistor together, on one of the transistors, connect the wire going to the base and just bring it to its own rail somewhere over here, away from all the other. Now, between both the emitters of both transistors, hook them together and then hook that to ground. So I'm going to have to... Okay, we're nearly done now. Now, just grab another wire and hook the collectors of each transistor together as well. And hook some sort of jumper lead to that, because that is going to go to one of the primary coils. There. Just like that. Now, just on your power rails, hook your 1 microfarad capacitor. I am going to be using 2 of these capacitors, but one will work just fine. Now, on each power rail, hook up a wire that you can connect to your power supply to, like so. And then also grab a long wire and hook that to the positive of your circuit. Like on there. Hook it to your positive of your circuit. Now, this between here and here, between the positive and the the middle pin of these tip 31Cs, that's where your primary coil is going to go, and then your secondary coil, one end, the bottom end here, is going to go to this lead that we pulled out over here. So just go hook it up like that. So this goes to one side of the primary, this goes to the other side of the primary, and then the one side of the secondary goes here, and the other side of the secondary is where your high voltage will be. And then hook up a power source. I'm just going to be using this bench power source. Now, with all that hooked up, you just want to make sure that, I forgot to tell you this, put some sort of thermal pad or thermal paste to hold your transistors in, so they make a good thermal contact to this heatsink. And even so, if you're going to be running this at maximum power, you really do want to put a fan on there, but I'm not going to because I am not a very good example. Anyway, this circuit can handle anywhere from 10 volts is when it starts working, 10 volts to probably about 50, but it'd get very hot at 50, so I only run it to 30, which is the maximum of this power supply. So you can see it doesn't draw any current. That's not right. What is wrong? Hello? Whoopsie, I forgot to connect this pin here on the far right of each transistor to ground. So transistors won't actually get any power. Now you can see it draws some current. There is no high voltage, and you can see bringing my hand near it changes the currents. Now if I grab a fluorescent light bulb, you can see it lights up. Now, like I said, this circuit is rated for much more than 11 volts. So, yeah, you can see it draws some lamp. Now it glows very brightly, and if you look very close, there's no corona, but it will zap the hell out of you. I don't feel anything. Let's see how hot it is. Yeah, you really do want to put a fan on that. That hurt. There we have a fan running off a 9-volt battery, 12-volt fan. Yeah, it's not running at its maximum capacity, but it's blowing enough air. So, let us turn my power supply on. And it's pretty cool if I just grab this cold cathode fluorescent tube. It's not, oh no, it works. It lights up, not a bunch, but if you saw in my intro, what I did is I connected each electrode of the cold cathode fluorescent tube to ground, just by shoving some wires in here and putting them to ground. So I'm going to do that now. Now that it's connected to ground, you can see it lights up much brighter. It's much better. See, it's not too bright on this output here, but around here, it's much brighter. Oops. Let's see if it can light up a big fluorescent bulb. Yep, it can. It's not super bright, but look, definitely can. But I think the effect is more noticeable using smaller fluorescent globes. So cool. If you're wondering, can this power a plasma globe is tipping it. Can this power a plasma globe? It doesn't look like it. Anyway, I did try sticking that into here when it was longer. It didn't do anything. I think you just need high voltage. So if you have more than 250 tens here, on 30 volts you wouldn't get much high voltage. It can draw arcs to your finger. Now, because it's such high frequency, the arcs are not dangerous to touch. They just burn your skin. And that's not very fun. Can't say it. Camera's not good at close-ups. Well, thank you for watching, and see you in the next video.